You know that notification you get? Meeting moved to 3 p.m. You tap OK, and boom, your calendar is updated. Seems so simple, right? Well, behind that one little tap is an entire invisible team working at lightning speed and in perfect sync just to make sure you and everyone else gets the message. So let's pull back the curtain and dive into this hidden world of digital teamwork.
So let's really picture it. The organizer of your next big meeting has to push it back an hour. They click save, and what feels like a split second later, your phone buzzes. How in the world does that signal travel from their computer to your screen and to the screens of maybe dozens of other people without a single person getting missed?
For the software engineers who build these things, this is the real challenge. It's not just about sending an email. Oh no. It's about building a system that can handle thousands of these updates a minute, guaranteeing that every single person is notified and doing it all with almost perfect reliability. Think about it. One missed notification could mean one very important person misses a meeting, so failure is just not an option.
To solve this puzzle, you don't just write one big piece of code. Instead, you build a team of highly specialized services that all live in the cloud. Let's think of them as 4 different workers, each with one very specific job to do, passing the task down the line, like a high-tech assembly line. All right, let's meet them.
First up, we have Amazon SQS. We're going to call this worker the in tray. See, when that meeting gets updated, the request doesn't just fly out into the ether. It's placed very neatly into this digital queue, just like putting a memo in a physical in tray on a desk. This makes sure every single request is logged and waits its turn, which is absolutely crucial for making sure nothing gets lost in the shuffle.
Now, our next team member is AWS Lambda, and this one is pretty clever. We'll call it the processor. This isn't a program that's just sitting around waiting. No, this worker literally springs into existence the instant a new request hits that in tray. It immediately grabs the task and gets to work. You can really think of it as the brains of the whole operation.
Okay, so the processor has the task, but who does it need to tell? It has no idea. So its first move is to check with Amazon DynamoDB, which we'll call the guest list. This thing is a super fast database, basically a digital address book that holds the details for everyone invited to that specific event. The processor asks for the list and it gets an answer in just milliseconds. It's incredibly quick.
Once the processor has that guest list in hand, it's time to actually send the notifications. And for that, it taps our final team member, Amazon SNS, the broadcaster. The processor hands over the update message and that entire guest list, and the broadcaster's only job is to blast that message out to everyone on the list at the exact same time. It's all about simultaneous delivery.
Now, it's really important to understand the difference between our first and last workers here. SQS, the in tray, is a one-to-one system. One message goes in and one processor picks it up. That's it. But SNS, our broadcaster, is totally different. It's a one-to-many system. One command goes in from our processor, and the message goes out to everybody on the list. They perfectly bookend the whole process.
Okay, so we've met the whole team. Now let's put it all together and watch them work in perfect sequence. We're going to follow the entire process from start to finish in 4 really simple steps.
So here's the entire assembly line in action. First, a request arrives in the in tray. That immediately wakes up our processor. The processor then grabs the guest list and then tells the broadcaster to send out all the alerts. And then, and this is so important, it performs a final cleanup step, deleting the original request so no one gets a duplicate notification. It's just a clean, efficient, and totally automated flow.
Right, a system that moves this fast needs to have a very strict set of rules to stay organized. And just as importantly, it needs to know exactly what to do when something goes wrong. Because trust me, in the world of software, you always have to plan for mistakes.
You can think of this table as the team's instruction sheet, or maybe a cheat sheet. In the real world, they're called environmental variables. Before our processor even starts its job, it reads these instructions. This sheet tells it the exact address for the in tray, the precise name of the guest list database, and which channel to use for the broadcaster. This makes the whole system super flexible, because you can change the addresses without ever having to change the code itself. But what happens if the guest list is empty or the broadcaster has a problem? A poorly built system would just crash. But this one is designed to be resilient. If it can't find any attendees, it doesn't panic. It just stops and makes a note of the problem for someone to review later. If the broadcast fails, same thing. It logs the error without bringing the whole system down. It's designed to report errors gracefully, not to freak out.
So yeah, we've gone really deep on one tiny, specific task.
a calendar invite. But why does this one little process matter so much? Let's zoom out for a second and look at the bigger picture.
You know, the official documentation for this system really says it best. It's all about automating a process for efficiency and reliability. By breaking a big problem down into these small, specialized automated steps, engineers can build systems that are unbelievably powerful, fast, and trustworthy. This idea is really one of the fundamental building blocks of almost all modern software. And the scale of this, it's just mind-boggling. It is not just your calendar. Every single time you get a shipping notification, a social media mention, or a password reset link, a very similar invisible team is working just like this behind the scenes. These tiny, automated workflows are firing off billions and billions of times every single day, creating the seamless digital world we all kind of take for granted. So the next time your calendar pings with an update, you'll know. You'll know it's not just one thing happening, but a perfectly choreographed dance by a team of invisible digital workers. And that kind of leaves you with a cool question to think about. What other silent, invisible engines are humming away just beneath the surface of the apps you use every single day?